Recall the following example. Rotator cuff surgery has a 9% chance of success. The surgery is performed on 3 patients. Find the probability of surgery being successful on exactly 2 patients. We've already established that this is a binomial experiment. Why is it binomial? Well, there's only 2 outcomes, success or failure. Success occurs at p equal to zero point 0.9, and failure q occurs at q equal to zero point 0.1. We have a fixed number of individuals we're looking at, just 3 patients. So that means that our n is 3. And now I want to know each surgery is independent of each other, which means that one surgery shouldn't affect another, and the probability of success doesn't change. So we said this is binomial. X follows a binomial distribution with an n of 3 and a p of zero point 0.9. Now, for this particular problem, I want to know what is the probability of being successful in exactly 2 patients. So we're going to define x as, let x equal the surgery is successful, or a successful surgery. In this case, we want to find the probability that x equals 2. So we're going to develop what's known as the binomial formula. And the binomial formula works like this. Because these things are independent, remember that means we can multiply probabilities. And here's what we have. We have 3 patients that come to get a surgery. Of these 3 patients, we want exactly, the word exactly, we want exactly 2 of them to be successful. We know probability of success occurs at 0.9. That means to calculate the probability, it looks like this. For the first patient, this is a successful surgery. For the second patient, this is also a successful surgery. If I want exactly 2, that means one of these surgeries has to be failure, so we'll let the third surgery be a failure. Now, because they're independent, what can we do to them? We just multiply them. So we multiply 0.9 times 0.9 times 0.10, and I get 0.081. Now, the problem with this, though, is this is explicitly saying that the first surgery was successful, the second surgery was successful, and the third was a failure. Is that the only way to get exactly 2 successes out of 3 attempts? No. We can reorder the successes and failures, and now do like this. Let's let the first surgery be a failure, and the last 2 be a success. And here we're left with, again, 0.1 times 0.9 times 0.9, just in a different order, but they're still equal to 0.081. Are these the only 2 ways to actually order these successes and failures? No. We can move the failure around again. And so this time we can let the second surgery be a failure. So we have 0.9 times 0.1 times 0.9, which again is 0.081. Are there any other ways to rearrange the successes and failures here? The answer there is no. So we can just add up all these probabilities now. When we add these up, we're going to get 0.243. Now, this is going to lead us to the binomial experiment, or the binomial formula. And let's look at how we can actually derive that formula. In this formula, or for this particular problem, what you've done is you've reordered the order of the successes and failures. Success and failure has to occur the same amount of times for each one of these orders, but we can rearrange the way we have the successes and failures. A quicker way and a more efficient way to calculate the number of successes and failures, or the number of orders you can get, is by using what's called a combination. And this identifies a number of ways to order n items with x successes. We write it as n c x, or another way of saying this is n choose x. So we have, for instance, in ours we had 3, our n was 3, our x was 2. So this was 3c2, or 3 choose 2. And this symbol here, if you've never seen it before, the exclamation point, is what we call a factorial. And a factorial is defined like this. N factorial is equal to n times n minus 1 times n minus 2 times all the way down to 2 times 1. So what that means is, let's say n was equal to 5, then n factorial would be 5 factorial, and 5 factorial is 5. Then its next part would be 5 minus 1, which is just 4. Then it would be 5 minus 2, which is just 3 times 2 times 1. So all it does is it multiplies the factors, starting with the number n, all the way down to get to 1. And so here we look at 3c2. 3c2 is equal to 3 factorial over 2 factorial times 3 minus 2 factorial. We can clean this up to be, well, 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. And then 3 minus 2 is just 1 factorial, or just 1 factorial, which is 1 factorial. So look what happens. You have 2's on top, 2 on bottom, they cancel. You have all these 1's sitting at the top and the bottom. These will cancel. So you're left with 3 over 1, which is just 3. This 3 represents the number of ways to order these successes and failures. And notice we got 1 way, 2 way, 3 ways to rearrange the successes and failures. So these are the number of combinations you can get. So we're going to build the binomial formula for this. And to start the binomial formula, we always start off with the number of ways you can rearrange success and failure. And we call that NCX. The next part, notice this. You have the probability of success twice in each one of these arrangements. But why do you have that? You want 2 successes. And we're going to let x equal a success now. So when you see the variable x in a binomial, that means a success. So when we write this out, we know that the probability of success, if you look here, probability of success is 0.9. We call that P. How many times do we have P sitting here? We have it twice. 1, 2, 1, 2, 1, and 2. Why do we have it twice? Well, it's because x is equal to 2. So this is literally breaking down to n choose x, the number of combinations, and then it's going to be P raised to the x power, because there's so many times you want to see P. And then you have failure. Well, failure is what we call Q. And how many times do we have Q? Well, here we have it 1 time. Here we have it 1 time. And here we have it 1 time. Why do you always get 1 in these sets of 3? Well, you get 1 in these sets of 3 because 2 of them have to be success, which means the remaining has to be 1 for a total of 3 events. So same thing here, except we can let x be the number of successes. Well, how many failures will you always have to have? Well, we always start with, in our case, our n was 3. We took 2 successes. How many failures did it leave us with? 1. So we do the same thing here, except we write this as n minus x. This is the binomial formula. And we can use it to calculate any binomial probability, such as if we do 3c2 times, well, your P is 0.9, raised to the x, well, your x is 2, times Q, which is 0.1, and that's raised to the, well, 3 minus 2. We know that 3c2 is 3. This term right here is 0.081, because that's what we calculated over here. And we know that when we do that, we get 0.243. So let's look at this example. Assume that 13% of the people are left-handed. If we select 5 people at random, find the probability of each outcome described below. So again, let's make sure that let's verify that this is binomial. The first thing we're going to do is look at, do we have a probability of success? In this case, our probability of success P is 0.13. Those are left-handed. Q is equal to 1 minus P, or 0.87, which represents right-handed people, basically. If we select 5 people, so that 5 is going to be my n. It's a fixed number, so n equals 5. Me being left-handed or you being left-handed should not affect another person being left-handed, so they're independent. And the probability of success isn't going to change. So this is binomial. We say this, x is approximately binomial with an n of 5 and a P of 0.87. So the first one says to calculate that there are exactly three lefties in the group. So what we're calculating now is the probability that X is equal to 3. Because remember, X is the number of successes you want. If we were to write this, we would write it like this then in terms of the formula. Well, we have how many people? 5. We're going to choose how many? 5C3. So 5 choose 3. Probability of success is 0.13. And how many successes do I want? I want 3 successes, so it's 0.13 raised to the third times. What's the probability of failure? 0.87. And how many am I going to be left with once I take that away from the total number? So I have 3 successes, which means I'm left with 2 failures from the 5. And this is the actual formula. If we calculate that, we're going to get 0.0166. It's a probability of getting exactly 3 lefties in the group out of 5 people. The next one says that there are at least 3 lefties in the group. Well, let's talk about that. At least means what? Well, think about it like this. In this case, you can have, let's let our x's be 0 lefties, 1 lefty, 2 lefty, 3 lefties, 4 lefties, or 5 total, all 5 lefties. Here I want at least 3. Well, at least 3 means what? 3 and anything bigger. So the way I write that is, this is the probability that X is greater than or equal to 3. Well, when we write this out, to write it using the notation, this means that probability that X can be equal to 3 plus the probability that X can be equal to 4 plus the probability that X can be equal to 5. So when you calculate that, what you're calculating is the first one, X equals 3 would be 5 C3 0.13 raised to the third times 0.87 plus next one 5C4 times 0.13 to the third times 0.87 squared. I'm sorry, times 0.87. Do that one again. These should actually be 5C4 means I want 4 successes. So 4 successes here and then 1 failure here. I forgot the 2 over here, by the way. Plus 5. Not a very good color right there. Plus 5. C5 0.13. This time raised to the fifth one, 5 successes, 0.87, and no failures. And if I calculate this, I get 0.0179. Now, as you can see, this is a little bit, it's not hard. The concept isn't hard, but the actual math, calculating all of these different combinations and the multiplying like that can get kind of tricky. There's a much quicker way to do this. I'm going to show you in a video using the calculator how to calculate this. But we're going to get this 0.0179 either way we do it. And let's look at the last one. The last one says that there are no more than 3 lefties in the group. Well, no more than 3 lefties means what? Well, here's 3 again. No more than 3 means you're going to go back this direction. So this is the probability that X is no more means less than or equal to 3. And again, this will be probability that X equals 0 plus the probability that X equals 1 plus the probability that X equals 2 plus the probability that X equals 3. And if we calculate that, we're going to get 0.9987.